Today on the Nivlac 57 YouTube channel, we're going to show you how to set up a 9-inch third member for high performance use. In today's video, we are starting our prep for the No Name Nationals, which is coming up September 30th to October 1st in Sikeston, Missouri. The particular car that we are getting ready is my dad's 1974 Chevrolet Nova. As a lot of people know, Jeffers Motorsports Park is an 1/8 mile track, so we need to set up a 1/8 mile gear for the car. While we are at it, we are also going to take a little bit of weight out of the car and install this aluminum case that I bought my dad for Christmas a couple years ago, and we're going to finally install in the car. Now, everybody has their techniques and their opinions on how to set up a 9-inch, and we're just going to show you some of the ways that we do certain things and what we've had success with. Obviously, got to give a disclaimer. I make no guarantees that this will work for you, so use this advice at your own risk. So without further ado, let's get this thing assembled and into the car. So the gears that we are changing out in the Nova we are going from a 315 gear to the gears that you see here, which are a 411 gear. These are brand new Richmond gears. My dad has had them sitting on the shelf for quite a while. Your main challenge with assembling a third member like what you see here is getting your pinion gear, which is this guy, properly engaged with your ring gear, which is right here. So you have to get these guys properly meshed with each other so that they have the adequate backlash, and they are making a good pattern on the gear faces so that neither of the gears are being overworked and have a possibility of breaking. So the way that you do that is your third member case has adjustment in it so that you can adjust where the ring gear is located in this orientation, and you can put shims like these guys, which are varying thicknesses in between your pinion retainer and your differential case. This basically moves the pinion gear in and out, and the adjustment collars in the case will allow you to move the ring gear from side to side. And you also need to consider that you need to get proper preload on your bearings so that everything will wear in and live a long service life.
Okay guys, before you start assembling your rear end, make sure that you take a minute and just double check that everything's going to fit. One of the things that I've run into in the past is that the back of the cap can hit this indent, and the side of the cap here can hit these ribs right here. So what you're going to want to do is put it in there and verify that you don't have any interference with these parts. And I can reach in there and feel that this has got clearance at the back of the nub, and there's clearance on the side. A good way to do this is to take a long feeler gauge and stick it in between the cap and the housing and just move it all the way around and verify you got clearance. Another thing that you want to do is verify that your new spool will work with your old axles. Different manufacturers have different spline cuts on the angle of the spline itself, so you want to verify that this is actually going to work before you try to assemble it. And it does. It's a perfect fit. Old bearings are good for using to press new bearings on with. I recommend that you take a belt sander and sand this surface out so that it doesn't push down on top of the new spool.
Press on all of the applicable races and bearings, making sure that all of the surfaces are clean and adding a dab of oil to all surfaces that will have a bearing or race pressed into them.
One of the things that you have to get right in assembling your pinion is the bearing preload. What that does is it keeps the bearings from prematurely wearing or having being too tight, creating excessive heat, and it makes everything more stable for the long run. In order to do that, we're going to use a solid shim instead of the factory crush collar. The advantages of the shim is that you can disassemble this at a later date and reassemble it with a different pinion or the same pinion if you have to fix the seal. The other advantage is it adds a little bit more stability to these bearings when you're running a trans brake car. The factory uses the crush collar because it's very quick to assemble. They put this in, they bring it down to a torque, they measure the resistance, and the assembly is completed. In order to set the preload for the pinion bearing, we have a solid shim with a series of small shims that'll be used on here. What we will do is we'll assemble this temporarily using a tool that I made just to press down on the bearing to get the right preload. We'll determine that by trying to rotate this and verifying what the rolling resistance is. Then once we have the right shims in there with the press pushing down on this to simulate the nut being tightened, then we'll disassemble it and put it all together with the pinion nut. We're going to start with a 12 and a 20 shim. I haven't even pushed the bearing the whole way down on, and I can already tell that there's not enough shim in here to space the bearings to have the preload be correct, so I'm not even going to push this the rest of the way on. The advantage of doing the preload check with this tool is that we have changed shims 5 times already. We would have had to have taken a nut on and off of those threads. What a lot of guys will do is they will take a pinion nut and cut the end of it off so that it reduces the risk of damaging the thread. I find that utilizing this speeds the whole process up. Through this series of adjustments, we got to the point where we were at 5 inch-pounds of resistance, and 1/1000 more took us up to 15 inch-pounds of resistance. So we were able to replace one of the shims in the stack with one that was 0.5 thinner, and now the rotational resistance is 10 pound-inches, which when you go through the multiplication to the center of this is going to come out to be 14 pound-inches, which is right in the middle of the specification of 13 to 15. Next item we're going to work on is we're going to install the spool onto the ring gear. These ring gears have a slight interference with the spool, so I like to put them in the press rather than using the bolts to pull it up. You put the bolts in just to get the proper alignment. And let's start putting the bolts in. Here's another tool that I made. It's a 33 spline axle that's been cut down to a hex shaft. We're going to stick this into the vise, clamp it down, drop the spool on top, and torque all the ring gear bolts. Okay, the next part we'll be working on is trying to get the pinion depth set. On the back of the gear, you'll see 1.010. That is this distance to the center line of the axle. To determine the pinion depth, I'm going to use a pinion depth gauge. And this was a gift from my wife one Christmas. And it comes with 3 standards, 2 inch, 3 inch, and 4 inches deep. I know from past experience that the 9 inch will use the 2 inch standard. And the first thing you do is you calibrate it so that when this is in, the reading is 0. The way this tool works is from this point to where we just calibrated the 0 is exactly 2.00 inches. What we are trying to establish is the back of the pinion, which we will measure here to this face, will be 1.01 inches. One of the challenges that we have to overcome first is identifying the center of the axle relative to this surface. It may be higher or lower, and what we're going to do is we're going to measure across to what that dimension is from this face. We know that this bearing is 3.25 inches. So we're going to determine what that half dimension is, find out what the actual dimension is, take the difference, and that's going to be part of the calculation that we need to do the pinion shim calculation. Before you disassemble this, make sure that you identify which side the bearing caps are on. This, I put an R on here and R on here because this is the right side of the housing. Okay, 2, 1.9, 1.7, 1.7, 1.76. Alright guys, so when we use the depth gauge to determine this distance here, we saw that the gauge moved 0.376 inches shorter than the 2 inch. Doing simple math, that comes out to 1/624. We know that the housing is 3.25 inches divided by 2 is 1.625. So the axle center line is 1/1000th of an inch further back. What does that mean? That means when we put the tool on there, the back of the gear said 1.010 minus the 1/1000ths. Our target is to set the pinion depth at 1.009 inches. We put this in and make sure that it's on the high part of the pinion depth gauge. And we are measuring 1.004. 100 minus 1.004. We come up with 0.996. So 0.996. And we need to have a 13 thousandths shim. Alright, after adjusting the shim a few times, the depth gauge moved 0.991, subtract that from the 2, we have 1.009, 1.009 matches what we were looking for. So now we can move on to the next step.
Alright, now that we have our pinion depth set, we're going to install the ring gear and the spool.
Alright, we gotta take it up halfway to 40 pounds-feet.
So the whole point of setting the pinion depth like we did before was in order to get a baseline on the gear mesh of the gears. The manufacturer of the gear has some sort of test fixture, obviously, and they are able to run the pattern on the gears to give you a starting point for your pinion depth. So the next thing you need to set is your backlash, which is the amount that this gear is able to move back and forth without your pinion gear moving. From there, once we have our backlash set, we can take the pinion gear out. Then we can set our bearing preload on our carrier bearings. And then from there, we can run a pattern on the gear mesh, and that will tell us if the gears are in proper alignment with one another, and we can make adjustments to either the ring gear location this way or the pinion gear this way, and that will get us to a point where we have the optimal backlash, proper bearing preloads, and the proper gear mesh. So in order to measure your backlash, you need a dial indicator with a magnetic base, kind of like this one. But what you will notice about this case is it is an aluminum case, so it's kind of hard to hook a magnetic stand to an aluminum case. So in order to fix that, we made this little plate, which you bolt in here, and that basically gives us a spot to stick our magnetic base so that we can check the backlash. So once you have your dial indicator in place, you want to set it so that it is contacting the gear tangentially, and then what you're going to want to do is push it one way and zero the dial indicator out, and then push it the other way to measure your backlash. I'm measuring, looks like right around 7.5 thousandths, and we want 8.
Yep.
Okay, so I'm gonna try to basically loosen up the gear. So to loosen the gear, you want to move it this way. So we need to loosen the nut on this side and tighten the nut on this side.
You can show the wrench too. Oh, that's too much. There you go.
So my dad made this little wrench, which basically engages with these nuts and allows you to change the nut position. Alright, that was probably too much, but we're about to find out. Perfect. So now that we have our backlash set, we will now take out our pinion gear, and that will allow us to rotate the spool freely, and that will allow us to check the bearing preload on the carrier bearing. Okay, now that we have the pinion support and the pinion gear out of the housing, we are going to measure the bearing preload on the carrier bearings. My dad has already felt it by hand and it is way too tight, so we are going to loosen one of our adjustment nuts and use the tool that my dad made, which is a 33 spline axle stub on this end and an 1.1/8" socket on this end. Then we will measure the bearing preload using a torque wrench and adjust the preload to get it to where it needs to be by adjusting just one side. Yeah, the whole point of setting the backlash before was just to get us in the neighborhood.
I'm going to say
Looks like about 12. Yeah.
nice.
Good enough?
Yep.
Okay. So we set this to about 12.5 inch-pounds or pound inches, and it's good either way. So now we can do final assembly of our pinion gear, or hopefully final assembly, assuming it gives us a good pattern.
Just a tiny bit, just enough to allow things to move freely. Have to drive that in.
Okay, this differential housing's a little weird. Normally there is, what, a retaining plate?
Yeah, it's a like a spider washer that locks in place, or a spring clip. What are they called?
C-clip?
Yeah, it looks like a C-clip, but
Yeah, an internal C-clip.
okay.
Yeah, normally there's an internal C-clip or some sort of spiral lock type arrangement, but this differential housing just uses two screws that overlap the pilot bearing, and you basically just install them and they keep the pilot bearing from going anywhere. Alright. So one thing you have to be worried about when you're changing your third member is your distance from the drive shaft yoke to the face of the differential. If that distance changes significantly, you're going to have to go to a different drive shaft, and just something you need to consider. We are trying to avoid that on this particular conversion. The distance from here to here was 8 7/8 on this differential, and on the differential that we took out, it was 8 13/16. That 1/16 of an inch is not worth chasing, so we are good to go. All right, now that we have our completely assembled pinion support, we can do something that is called checking the pattern of the gear. So in order to do this, you have some sort of a compound. I don't know if it's paint, whatever it is. You have some sort of compound that you brush onto the gears. Basically, you want to run this portion that you have coated through the mesh so that you can see where the two gears are contacting one another. And what that will do is that will create a wear pattern in the compound, and it will tell you if the gears are touching each other in a good spot. That will provide a long-lasting life and be able to handle lots of horsepower. So we've already brushed that compound onto here, and we're getting ready to actually check the gear mesh. Ready? Mm-hmm. We had to adjust the pinion 1/1000ths from the factory recommendation, and it gave us this pattern. This should be good to go. There are lots of resources online on how to evaluate the pattern and how to adjust it to suit your needs. So I would recommend looking at those resources. This is sort of a subjective thing, and sometimes you can chase your tail, but it's worth it. So this thing is ready to go into the car.
Okay folks, a lot of folks have asked what the difference is in weight between a cast iron center section and an aluminum center section. We're going to weigh one. Cast iron comes in at 72 pounds, and the aluminum center section comes in at 59 pounds.
All right, that was a lot of work. We got this 9-inch all set up and it's ready to go into the Nova. Now, a lot of you are probably going to say, wow, it's worth every single penny to have somebody set this up for you and have it ready to go into the car. And I can say, yeah, you're not far off, but for guys like us that do a lot of them, it makes sense to have all the specialty tools. And since we're changing gears a lot, it makes sense for us to have the knowledge in order to know how to set one of these up. So with that, we're going to get these 411 gears installed into the Nova, and hopefully we'll be testing it soon for the No Name Nationals. Make sure that you like and subscribe. Consider becoming a member on the channel by hitting the join button down below. Leave a comment. We'll see you in the next one.